Hi, welcome to my video on the addition formulas for tan. In this video, which is number 3, we're going to do some proofs. So if theta equals tan to the negative 1 of 5, beta equals tan to the negative 1 of 2/3, show that alpha minus beta equals pi over 2 in two different ways. Well, let's look at pi over 2. I said pi over 4. And your pi is 180, so 180 divided by 4 is 45. So we're trying to get a 45-degree angle. Another way to convert pi over 4 is to multiply by 180 over pi. Pi's cancel. 4 and 180 is 45. But when I convert radians to degrees, I just change the radian to a degree and then work out the expression. Now we have theta minus beta. So let's do it two different ways. The first way I'm going to do it is if alpha equals tan to the negative 1, that's the arctan. That means that the tan to the negative 1, so I was going to say that's tan of alpha equals 5, true. And if beta equals tan to the negative 1 on 2/3, that means the tan of beta is 2/3. But we can use our calculator to work these out. And let's turn on the calculator, clear it. And we have our calculator here. So let's do inverse tan on the 5. And we get 78 point to the nearest degree. Let's go to the nearest 10, 78.7. So alpha is 78.7 degrees. Now let's look at, clear that, inverse tan of 2 division 3. And that gives us 33.7 to the nearest 10th. So beta is 33.7. And not only that, when we're doing, the calculator gives us the true answer. When we do inverses in relation to the trig functions, if it's positive for tan, it's between 0 and 90. So since these two are positive 5, positive 2/3, these answers are between 0 and 90. If this was a negative 5 or negative 2/3, this answer would have come out to be negative 0.78.7 or 33.7. Now, alpha minus beta is 78.7 minus 33.7, so we get 45 degrees. And again, 45 degrees is pi over 4. So that's one way we can prove that. So let's do it another way. Another way is to look at the tan of alpha minus beta using the formulas for tan of the subtraction. So that's tan of alpha minus tan of beta all over 1 plus. So this is a negative, this is a negative, and this is a positive. And this is tan theta tan beta. So the tan of theta is, the tan of alpha is 5. The tan of beta is 2/3. So that's 1 plus tan of alpha is 2/3 times the tan of beta, which is tan of alpha. Tan of alpha is 5. Better be careful. Do it right. Make sure. 5, and this is 2/3. And we simplify that. So let's simplify the numerator and denominator first. So we multiply these two. 5 over 1, that gives us 10 over 3. The LCD, this is a complex fraction, so the LCD for the numerator and denominator is 3. So if I multiply 3 by 5, I get 15. Multiply 3 by 2/3, I get negative 2. 3 times 1 is 3. 3 times 10 over 3 is, looks like the pen is used out. Just get a new one here for a second. 3. And 10 times 10 over 3 is 10. And that gives us 13 over 13, which is 1. So the tan of theta minus beta, make that alpha minus beta is 1. So that means alpha minus beta is 45, because alpha minus beta is equal to arctan of 1. If you use your calculator, you get inverse tan of 1, and that's, as you can see, 45 degrees. So that's 45 degrees, and 45 degrees is pi over 4. We already did it on the top. So that's 2 ways to prove that this is so, according to this proof. Let's continue. Let's prove that the tan of theta plus pi equals tan theta. So we have a proof. So we have a left side and we have a right side. The left side is tan of theta plus pi, and the right side is the tan of theta. And we got an addition formula, so that's tan theta plus tan pi. Oops, make sure the pi there. And 1, there's a plus, so this is a minus. The tan of theta, tan pi. Now, we can do it 2 ways. We can pick up the calculator and say, what's the tan of pi? Remember, pi, let's write it right here. Pi is the same as 180 degrees. So I can go tan of 180 degrees, and it gives me a 0. So the tan of theta, the tan of pi, which is 180, is 0. So we get 1 minus tan theta times 0. So that gives us tan theta. When we add 0, we get tan theta. And we get 1 minus tan theta times 0 is 0. So that gives us tan theta over 1, which is tan theta. So we make a statement that's the proof, since the left side equals the right side, put a comma there, it is an identity. Okay, and just to check that, I used a calculator on that, but what about if I didn't have a calculator? Well, if I draw this unit circle and put, this is, pi is 180, 180 is right here. This point on the unit circle whose radius is 1, this point is negative 1, 0. And the tan of pi, which is 180, tan is opposite over adjacent, but tan is also the y over the x. So the y is 0, and the x is negative 1, so the tan of 180 is 0. That's not using a calculator, we're just explaining it out according to understanding what trig is about. Again, the tan of 180 is 0. Now let's prove the next one. The tan of 45 minus theta equals 1 minus tan theta over 1 plus tan theta. Again, we have a left side, which is tan 45 minus theta. We got a right side, 1 minus tan theta over 1 plus tan theta. Okay, this looks like we can expand. This is the addition formula. So this is the tan 45 minus tan theta all over 1 plus tan 45 tan theta. And the tan of 45, you can use your calculator, it's 1 minus tan theta, and that's 1. And again, the tan of 45 is 1 tan theta. So that gives us 1 minus tan theta, which is what's here, over 1 plus tan theta. And just to show that on a calculator, that we clear that, the tan of 45 degrees is 1. And also another way is that if you draw the circle, and we're talking about a 45-degree rotation, and this circle, I got a radius of 1, so this point is 1, 0. So you rotate up 45 degrees, draw terminal arm, perpendicular, 45, 45. In a 45 right triangle, this is 1. X is 1, Y is 1, and the hypotenuse is root 2. So the tan of 45 is the opposite over the adjacent, or the y over the x, or 1 over 1, which is 1. The calculator is a fast way, but I'm just, again, reviewing the elementary trig. Okay, let's do one more that will end the proofs and the addition formulas for tangent. Prove that the cot of alpha plus beta is the cot of alpha, cot beta minus 1 over the cot of alpha plus the cot of beta. Well, we have again a left side and we have a right side. Left side is cot of alpha plus beta. That's the left side. The right side is right here, so it's the cot of alpha, cot beta minus 1, cot alpha plus cot beta. So again, we have the addition formula, but this time cot is 1 over tan. Cot is the reciprocal. So cot is 1 over the tan of alpha plus beta. And that's 1 over tan of the addition formula is tan alpha plus tan beta. Now make this a long line. This is the division line now on this complex fraction. Make this a shorter one. And this is 1 minus tan alpha tan beta. Okay, so notice we have 1 over, so that's the reciprocal. So 1 over this, so we'll multiply by the reciprocal. So that's 1 times 1 minus tan alpha tan beta all over tan alpha plus tan beta. So that gives us 1 minus tan alpha tan beta all over tan alpha tan beta. But we need the reciprocals. We need cots instead of tans. So that's tan is 1 over cot. Tan alpha is 1 over cot alpha. Tan beta is 1 over cot beta. Draw this long line here. There it is. And tan is 1 over cot alpha and times 1 over cot beta. So now that means we have a complex fraction. So the LCD is cot alpha cot beta. Cot alpha cot beta is on the numerator, and cot alpha cot beta is on the denominator. So we'll multiply this expression, each of these, by cot alpha cot beta. So 1 times cot alpha cot beta is cot alpha cot beta minus, when you multiply these two fractions by cot alpha, cot beta, they cancel out and we get a 1. And when I multiply 1 over cot alpha by cot alpha, cot beta, the cot alphas cancel out and I get a cot beta times, that gives us, let's see, there's a plus there. There's a plus there. I made an error. I didn't, when I transferred it, see that plus? There's a plus there. There's a plus there. So I multiply cot alpha, cot beta by this, I get cot beta. When I multiply cot alpha, cot beta by cot beta cancels out, and I get cot alpha. So it looks, top is okay, but the bottom is not. So the top is okay. So it has to look like this, but what happens, the cot of beta plus the cot of alpha is the same as the cot alpha plus the cot of beta. That's because the addition is commutative. We can switch those around. So if you had a 4 and a 5, 4 plus 5 is the same as 5 plus 4. So we can switch these around because of the commutative property of addition. And now we have the left side, which is equal to the right side. So since the left side equals the right side, it is an identity. Again, just a little bit different, but using that cot is the 1 over tan because the reciprocal ratio. And doing a bit of math here, we come up with this expression. So that brings us again to this video on proofs. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.